up, streamers, Twitchies? Is that what Twitch people are called? Twitch watchers? All right, looks like we're fish on. Let's, so yesterday was very exciting. We got 1,800 lines of code into, well, not really, it's not 1,800 lines of code, is it? But it's a lot. We added a lot to the time series forecasting notebook in TensorFlow. So we're going to continue on. So let's see if we can beat 1866 additional lines. Not that, so when you write more code, eventually you want to start writing less code so that the code you write is actually very good. But we're going to keep going through this. I'm going to get rid of this because we've moved on from replicating the n-beats algorithm. We've already got that. So we want to call back. Yes, we do. Uncertainty plotting. Okay, beautiful. Welcome in, Alex. How you doing, my friend? So we're just reiterating what we did yesterday. We got a whole bunch of progress done on the time series forecasting in TensorFlow notebook. We're going to keep pushing forward on that today. Oh, what's the GitHub notification? Deep learning course recommendations. Oh, beautiful. I'm really liking GitHub discussions. I think GitHub is like the ultimate social media. Maxwell, what's good? Because GitHub is, well, one of the ultimate social medias. It is based on proof of work, so you can see what someone has worked on. You can contribute to other people's work, and if something is good, more and more people will use it. So it's based off usefulness rather than sort of clout, which is what a lot of other social media networks are sort of based on. Okay, so let's get rid of this. One of the beautiful things, we've got a rule now. Every new stream we start, we're going to X out of all the tabs. How's that sound? That way, we come in fresh as a daisy. Boom. No tabs. We have one tab. Let's see how far we can get today. So, yesterday we left off, I didn't find a way to window the dataset using NumPy, but after the stream, I figured it out. So, I've got this function here, which is beautiful, and this function here to create windowed dataset, which is how we can turn, I'm going to put this here. This is turning time series data set into a supervised learning problem. I also need to tweet out the stream, so let's do that. Twitter. Going live on Twitch. Making deep learning for time series forecasting materials for new TensorFlow course. Boom. Come and say hi. Come and watch my fingers dance along the keyboard. Boom. Why am I keep opening up this Mac? I just want to open up the dance emoji, you know? Dance. And then let's get HTTPS www. I really should just turn this into Zapier, so it does that automatically. It tweets this out automatically, so I don't get distracted. And I'm just going to copy this, put it in the Discord. Zero to Mastery Discord, by the way. Supernova, what's good? Vig, how are you, my friend? Oh, can't use the @ symbol in Discord. I need to also let people know. PS, I will answer the questions above after the stream. Beautiful. All right, let's get out of that. Let's get out of the distractions. Cass, what's up? Welcome back. Thank you everyone for tuning in. Let's we've got a good amount of code. Like yesterday, this notebook was nothing, and now look where we're at. Like we've got a good amount of stuff here to work with. So today I really want to focus on, there's a few things. I made this to-do list earlier today. Can we beat 1866 additional lines? We actually did that. Make materials, so we did that. Next is make forecasting better. So how can I forecast on an arbitrary amount of steps? Create evaluation method for larger windows horizons. I've really been spending some time about what is the most bang for buck, what's the best for someone to know for time series, because although it can be cool to build like neural networks for time series, I also want to mainly show how to prepare data for a time series model, and also make sure people are aware of the caveats of time series predicting, because that's probably the main one. And this is kind of be like an anti-education on time series forecasting, because we're going to see where our problem is to predict the price of Bitcoin, but we're also going to see how poorly our models actually do on that. So it's kind of like a warning that's like, hey, if you're predicting on an open system, like a market, be very careful of the predictions your model puts out. But if you're predicting in a closed system, you can define a closed system however you want, but you could imagine it's something like a factory processing plant, and you want to figure out how many, if you're a delivery company and you want to figure out how many people you need on the floor for parcels. A closed system, you can kind of control the variables, whereas a market, there's too many things going on. Your model won't be able to capture everything that's going on. And we're also going to introduce a turkey problem, which is, we'll see that later on, but we've got a few things to focus on today. But that's what I want to prepare people for, is to not just say this is the be all and end all, but where to learn more. That's probably the biggest thing I can impart on students, is not so much the hard skills themselves, but the skill of wanting to figure things out. Build more modeling experiments. That's pretty vague. Specifically, let's try and get an LSTM model out the door and a Conv1D model, just so people can see what sequences are like. Sequence models can be used for. Oh, this is a big one as well. We want to create a multivariate time series. So right now our Bitcoin data is univariate, which means we only deal with one variable, the price of Bitcoin over time. We can make it multivariate, which is what a lot of time series are actually going to be, is you have multiple different things contributing to the one value. So for this, because it's Bitcoin data, let's implement maybe the number of blocks that can be mined. That will probably be another feature that we can engineer. Why are we doing Bitcoin? Well, because it's easily accessible and it's got all the parameters that we need for an example time series problem. And then we also want to, it'd be great if we could create a TensorFlow windowing function to complement the NumPy windowing function. Because right now our windowing function works for NumPy. However, because it is a TensorFlow course, you'll probably want to do it in TensorFlow. The benefit, of course, TensorFlow windowing equals can run on GPU. All right. Hey, Vig, you're loving the course? That's excellent. Okay, so you have experience using ARIMA. So that was what I was considering. What's ETS stand for, Vig? I was considering bringing in ARIMA, autoregressive something moving average. I'm pretty sure that's what ARIMA stands for. But considering this is dedicated to TensorFlow, I think that may be expanding on too much. So I think I'll put an extra resource for people who'd like to learn about ARIMA and other methods. I'm going to specifically focus on TensorFlow methods for the time series. That way it's not getting too large of a module, and because after all it is a TensorFlow course. Day Adam, hey, bonza to see ya. Excited for the bloody stream, mate. Bloody oath, copper. Sounds like someone in the country. Australia's saying that, my friend. Supernova says, wait, it's still May 18th where I live. Is Daniel from the future? Yes, I am. In fact, Australia is in the future to a lot of countries around the world. I think New Zealand, the easternmost side of New Zealand gets the sun first in the world, and then Australia's just after that. So, yeah, we're in the future. Welcome to the future, ladies and gentlemen. It is 19th of May. Okay, so are we really doing what we want to be doing here? Okay, baseline 2. I'm probably not going to do a moving average because I want to focus on TensorFlow specific methods. Maybe we could do a random forest regressor. But yeah, let's start running this. So I've got the data uploaded to Dropbox. I really should just move that to GitHub. Yeah, I'm GMT plus 10. I'm in Brisbane. Brisbane time zone. Yeah, GMT plus 10. All right, so we got some Bitcoin data. Here's the dates. We're using the closing price column rather than any of the other columns. That way we're just predicting one variable. Price, yes. If we plot it, this is what it looks like. So this is the current day for May 18th. That's when it goes till. May 18th, 2021. So we got this yesterday. And we're going to keep going. We can import it as a CSV if we wanted to. Get the dates as dates, not strings. That's where they come. And skip the first line. Yeah. Okay, so this is just importing data. Very important way to do things. Now, the reason why we can do things with CSVs here is because depending on how much time series data you have, this is something to note with deep learning algorithms as well, is that we got the entire history of Bitcoin data here, of prices, daily for the last however long it was, since 2013. Now, we only have a total of 2,787 time steps. So what do we know with deep learning is that, well, deep learning models usually take a lot of data. So I'm going to minimize this so I'm not getting distracted by a few things. So yeah, this is something to also keep in mind. I might write this down here. so I come back to it later. We're just doing a lot of raw code here. I'm going to come back and fill it out with annotations, text-based annotations later. To do time series often may not have very many samples, e.g. monthly equals only 12 per year, daily equals 365 per year, etc. And then we go here. Deep learning algorithms usually flourish with lots of data. Thousands of samples. Beautiful. Oh, thank you for that, Vig. ETS is similar to moving average, it's just exponential smoothing. Okay, so we get the Bitcoin prices here. We import them as CSV, just the same plot. And then here we go. Format data, turn data into a windowed data set. Training test sets for time series, univariate, multivariate. Okay, so if we get the Bitcoin data array and the prices, so we've got time steps and prices, we can get those. And then this is the wrong way to make train test sets for time series, splitting them randomly, because what do we want to do ultimately with a time series forecast? We want to use the past to predict the future. And now, if we had test data littered through here, this doesn't really help us predict anything that's coming over here. So this is the wrong way to do it. The right way to do it is if we do it like this. Train data, test data. So if we go there. This is some great insight here from Vig. I'm going to write this down. Vig says, for me, I use center data. I'm going to just copy this comment so that everyone on the stream can read it. So let me bring in this. Let's find out. Let's do this together, hey? I want my multivariate time series. Here we go. Okay, so this plot here. So we're talking about, Cass? So yeah, there's some forecasts that we made. I'll fix that up later on. So I use sensor data for predictions of forecasting. The toughest part of a time series when doing multivariate time series. Some input may have larger scale compared to the target. So inputs, let's write this, larger scale compared to target. And then we have, therefore, do we detrend all the data to keep them consistent? Detrend all the data to keep them consistent, or keep the same way. Sometimes they lose the correlation between them once they are detrended. So these are some great things. We're going to revisit this, Vig. My intuition is telling me that if we're using multivariates for deep learning, the beautiful thing about deep learning is that if we embed them in such a way that they go into a model, the deep learning model should be able to handle this feature transformation. But we will visit that once we start to incorporate multivariate to our own time series. We're currently working with a univariate. We've got a few more steps to do here. But this may be in this stream, it may be in the next stream. Is YouTube down? No. Oh, YouTube is down. Well, well, well. You can't watch my videos. No. Well, lucky Twitch isn't down, ladies and gentlemen. We're here. See, this is why we're on Twitch now. What if I was streaming on YouTube? This wouldn't work. Matt, what's going on, my friend? Good to see you. Let's keep going on with this. YouTube's down, Twitch works. So now Naive Forecast gets some pretty good results. Well, what do we find is pretty good, hey? We'll have to talk about that later when we add some. So here's our windowing function. This is what I created this morning with some great help from an amazing Medium article. So we can input an arbitrary long series of data, so such as this, and this function is going to, if you input it as a window, it's going to return it as this. So we can use the first 5 time steps to predict the last time step, depending on what the horizon is. Let me zoom in here so you can see this. And then when we make windows, we can put in X, which is an array, and we can create a window step, and then we can index on our windows with these window indexes, which is, this is a transformed array here as well. Transposed. So this is a 2D array of windows of size, window size. I'll get into the explanation of this as I write the annotations for this notebook, but right now, all you need to know is that if we put in a tensor like this, an array like this, into the make windows function, it's going to return something like this. So yTrain will get turned into train windows. And if we look at the first 5, we see here, so this is just one long array, and now this is an array of multiple different time steps. So we have the first 10 here, first 10, and then the next one will be shifted one step over. So it will start from here and then go on to the next 10 values. So that's our windowed pre-processing function. And then we have the labels here. So the labels, if we have the first 10 steps of yTrain, the label for yTrain is the next time step. Okay, so I'm not going to build a moving average, but we've got a dense model here. So if we fit our dense model for 10 epochs, we've got a simple dense model here, which is just one layer, ReLU activation, dense. I wonder what happens if we just use a linear activation here. Okay, it doesn't actually do too much. What if we just do no activation? Okay. So we're getting similar results here regardless of what activation we use. Okay, looks like ReLU is significantly better. Well, is that just luck of the draw? Dude, for YouTube to be down, that's pretty big. Like Google's hot, well, at least Colab is working. Is it still down? Wow. YouTube's still down. Like Google's whole business is like maintaining the internet. Well, a portion of the internet. And YouTube is a pretty significant part of the internet. So for YouTube to be down, No worry, we're on Twitch, but. So now I need a way to, I'm getting distracted here. I need to figure out what we need to do here. So we can make some predictions here with our model. What we're doing here is we're using, say, 10 time steps at a time. Yeah, this is, okay. So the window is, let me write this down. Create supervised data sets. Use 10 time steps to predict next. So this will be window size to predict next one time step. Horizon. Now these are two values that you can tune. So you might use a big window of, say, if you're working with yearly data, you might use the entire year's worth of data to predict the next one time step. Again, arbitrary values. These are hyperparameters that you can tune. So then if we, just going to clean up some code here. All right, yeah, okay, so our model 1, which is a dense model, is not performing as well as the naive model. So this is, we're going to see this later on. Yeah, dude, if AWS went down, that'd mean Twitch is down. And yeah, you're right, half the internet would be gone. So our naive model, which just predicts the previous time step as the next time step, is performing better than our dense model, our deep learning model. So this is, again, this is a big thing that I'm going to be highlighting throughout this. Naive model, often very hard to beat in an open system. This is what I found in my research and empirically. YouTube's back. Man, that would have been some frantic time in YouTube HQ. It's down! It's down! Okay, now we want to make a larger window and horizon. So if I want to predict 2 weeks at a time. So let's think about this. If we're stock market traders and we want to predict where the price is going with Bitcoin, how far, this is the $1 million question, right? It's like, how far into the future do we want to predict? So this is going to be, again, different per project. But for the case of ours, let's try if we use a horizon of 14, which is we want to predict 2 weeks into the future at a time because we're using daily price data. And we might use a window size of 140. So that's 10x the size of the horizon. So we use the previous 140 steps to predict the next 14. Again, we could change this. We could try to predict a whole year at a time using the last year. But it's really going to depend on what works best for your particular problem and how much data you have available. So, okay, this is a beautiful thing about our make windows function. We now have, I'm not sure why actually, our train windows 0 gets turned into train windows 0. We're using, this should be 140. Okay, we need a way to fix this. We need to fix the make windows function to work for larger time series. So see how ideally we want the window size to be 140. For some reason it's going down to 127. So we're using 127 values to predict the next 14. So this is where we should go. Back to the make windows function. I'm going to write this down. Fix the make windows function to work with arbitrary numbers of window/horizon. Supernova, is Greek yogurt a good meal if you are trying to cut? So that's quite. I could talk about that answer for quite a while, but the long story short is, if you're trying to cut, you need to eat in some sort of calorie deficit, and so ways to do that: eat less often, eat in a restricted time window. So, as in fast from 8 p.m. till midday the next day, so you're only eating for 8 hours, or do more movement, so you would expend more calories. Where does Greek yogurt fit into that? If you could eat Greek yogurt and you find that for you it satiates you for long enough that you don't get hungry, and thus overall you're eating less total calories, then it would be considered a good meal for cutting. But judging each individual food on its ability, whether it's a good or not good food to cut, there's no real answer for that, because there's videos and evidence online of people like, you can lose weight eating nothing but Twinkies. So an individual food, whether it's a good food or not on cutting, now don't get me wrong, I would not advise that, cutting on just Twinkies. I would always go high quality food. Am I a fan of Greek yogurt? Yes. Would I personally eat it for cutting? Yes, I would include dairy in my cutting meals. But I would keep in my mind that it almost doesn't matter what foods I'm eating, as long as I'm in a calorie deficit. So ways to do that, yeah, eat less often or expend more calories through movement. Okay, where's our make windows function? That was kind of a long-winded answer, but rather than just sort of give you the, eat that, don't eat that, I'd rather you sort of think about it in a framework that's going to be able to help you apply it to any food decision rather than just exclusively one food. Okay. So me personally, the way I kind of do it at the moment is because I train a lot, I almost eat whatever I want. However, because I'm kind of in tune with my body, I realize some days I'll skip dinner. So for example, Wednesdays and Fridays, I skip dinner. And that I find just controls my weight really well. And also allows my body to adapt. That's a Greek Orthodox style, which is also very Lindy. As in, it seems strange, but it's been around for a long time. So if something seems very strange, but it's been around for a long time, you can probably find that there's some truth in that. I should make more videos on health and nutrition. Really get my views succinct. Okay, so let's fix this function to work for an arbitrary size. So this is, I think, where we've gone wrong. This needs to be not +1. This should be plus horizon. That might actually fix it. Okay. What's gone wrong here? Yes. We need to reset the... Okay. Now, let's find out if that actually fixed it or if we've broken it. So if I set my window size here to 140, but did that make sense? Let me know if it didn't make sense. I can expand on it later. That's, well, maybe not now at the moment actually, because I'm coding. Okay, so yeah, we've got to think about how we can, maybe we can do -1 here. Because we're going to run into issues. Yeah. Index 229 is out of bounds. So let's find out where this index issue is coming from. This shape issue. Because if we print Windows step, let's get the last one of this. This is going to be that. And then I also want to get the last window indexes. Okay, this is where we're going wrong here. We're getting an overflow of steps. So we need some way to cut it down. Yeah, so this is TensorFlow's window function. They actually have a way to take care of this. TensorFlow window. Yeah, that's a tough thing, Cass. If you get banned by AWS... Drop remainder. Here we go. So that's what we need. We need some sort of way to drop the remainder. Because once we hit the... Yeah. Okay. So... I think we might be able to fix it here. Minus window size plus horizon. Okay, we're getting closer. We need a way to arbitrarily, I've been saying that word a lot, to minimize. We need this to get under the max length. Because see, if we remove the horizon here, we get this right up. Oh no, that goes higher. Minus windows. Okay, that's probably where we went wrong. We didn't have brackets there. Boom. That's what's up. We figured it out, team. Always get your brackets in. Now this should work for an arbitrary window and horizon. There is almost nothing more beautiful than fixing a function to work with arbitrary values rather than hard-coded values. Am I right? That's why I stream as well, because then you can call me out if I'm talking shit. You're allowed to swear on Twitch? I don't know. This is a kid-free channel. If you want your kids to learn machine learning, they can watch my streams. Okay, we've got something wrong here. Window size. Oh, okay. This is where we need to do the -1 thing up here. Because otherwise we hit the endpoint of the index and... Okay, we still get something wrong here. We need the -1 here too, I think. We'll find out. Boom. Fish on. Fish on, team. You know what I've been thinking about as well? Is I'd like to build a treadmill desk because I spend way too... if I'm going to be in the tech field, I hate sitting down for long periods of time. I've only got like 3 to 4 hours of sitting in me. So I'll be like, how could I, like, instead of even standing is not that great, like standing in the same position for the same amount of time. So I want to walk and code. That would be a fun experiment, I think. Now let's see if our function works with a larger window size. So see, yeah, we get, when we try to predict a larger window, we get a larger error, which makes sense because the more steps in the future you're trying to predict, the worse your model is going to be. Okay, so this is great. It looks like our code is working. All right, so here's where we got busted up. So what? Yeah, we need it to. It wants to look at 139 picture samples. So window size. No, we want. What size is the training window? Because we out here grinding. All right, 139. I don't like that. I want it to be an even 140. Where are we going wrong? Where are we going wrong? Let's get rid of that cell. Really want to make this window function a beast. We're going to do it with TensorFlow later on. Death Star, welcome. Yeah, you're totally right, Cass. Refactor once you've got something. Okay, yeah, so I want to make my window. So the windows, when we make the window size, it doesn't make sense for them to be -1. Why don't I move the -1 into here? It can't be that easy. It was that easy. All right, friends, we just fixed it again. Some great milestones that we've just hit. I tried a random forest regressor to do like earlier and it didn't work. Why doesn't this work? It should, but it doesn't. Okay, so now I want a way to arbitrarily predict. Okay, so this is where we're getting something wrong here. So we need to fix our evaluate preds function. Where are these extra values come from? Why are we missing 2 indexes here? Samantha, what's good? Welcome to the stream. So why test? I see. Model 1 preds. Okay, so we do need to get some cutting off at the end as well. Okay. I see where we're getting. Because what's the length? Yeah, so our window of 10 we need a way to line our data up. Samantha, that sounds like a great idea. How to transition from notebooks to VS Code. see if I get the last five of each of these, we might get a hint at where our data is getting cut off. I see. So we don't quite reach the end. See, if we go here, we want this. We want this index to hit oh. What if we plus 2 to that? Yeah, okay. That's where we run into an issue. Yeah, you might want to look into NBDev. And if we change this to maybe because it's It was a great, this was a great article on window creation for NumPy. This is a really great article. Okay, I think I'm way too deep. I need a way to Vertex AI platform. What is Vig saying here? Oh. This is very good. Thank you for that. I'm going to look into that. White paper for MLOps. I'm going to look into that later on, so I don't get distracted now. But let's come back to here. Let's just make this function work so that we can move on with our lives and build more models. Because the TensorFlow function has a way to handle this. Thank you for that. So it's going to miss out on a certain number of steps at the end. So we see here that the last index doesn't get included. So that includes it there. What if we add +1 here? That includes it there. Beautiful. All right, fish on team. I think we've just solved that again. A little bit of experimentation, that's all you need. Beautiful. First window's 149. Does that get fixed? Why doesn't that get fixed? 149. How is that 149? Okay, I think we're good. Let's try down. Damn, Vig, you got me real keen to check out. Boom, fish on. We fixed our function. Team. I'm going to read about that tonight, actually. I love having a new thing to look up. I'll be back. Ah. Would you look at that? A wild bottle of San Pellegrino made itself known. Let's dig into this together. So now we have a pre-processing function. See how much time you're going to be spending on your pre-processing functions? Unbelievable amount of times. Although it does work with NumPy, we are going to build a TensorFlow version of it too. And that way it'll make it work with tensors. So now our dense model is working. Let's work on some predictions. Okay, we don't want that. Can our model make a forecast? %, Cass. Yeah, so that's why we need to reshape it. Wonderful. I'm going to be digging into ML Ops for my next project, so stay tuned if you want to see live streams of that. Once I've finished the course materials for this, which is this, we're on the last one, I'm going to be working on my biggest project ever. If you thought this was big, this is a course. But I want to work on a full stack machine learning application. ML Ops, the whole thing, data collection, you name it. We're going to be pumping it out. Okay, so if I want to predict and plot predictions as well, I need to get some date times. Why didn't that give me NPA range? Why didn't that give me 14 days into the future? Horizon is 1. There we go. Why is the horizon only 1 when I've set it here? I've got some Lana Del Rey songs stuck in my head. So future dates is now an array. It would be much better if we could functionize this, so we're going to do that in a moment. Beautiful. There we go. So here's our model forecast. Can we have model 2 preds here? This is going to error. Oh my goodness. Whoa. Colors. So the reason why we can't plot model 2 preds is because they're in this format. They're in Windows. But what if we indexed on the last time step of each of these? What does that give us? What's this shape? Okay. I think this is plottable. Or is it? So if we... No, that's going to give us its last window. So it's training on 140. How can we visualize this? Do we create... Is this a moving average forecast here? Um, why do we miss out on so many variables here? Huh? Ah, here we go. Okay, so we only have 4. So this misses out on a whole bunch. So we lose these values here. I think I know why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's a horizon size. We lose the horizon size on the back end of test windows. But that makes sense because we can't... I need to stare into space for a while and think about something. Do we lose any at the start? These should be identical. Yes, they are. Do we have equality? Thank God. So I think I know how to get a proper evaluation. Because see, if we make multivariates, no. Our model is trained on all the data. This is some funky stuff. I need to break it down a little. So when we create a forecast, our model isn't trained. We need to be aware that our model, of course, it's not trained on the last time steps of our test data because it's the test data. That's fine. But if we want to make a prediction, okay, this is actually all right. So Model 2 forecast can't actually be compared to anything because it's a forecast. Derp. Oh. Forecasts can't be compared to anything because they're a forecast. Derp. Shocking. But if I make predictions, okay, this is where we need to figure out what the hell's going on. Yeah. So the preds are going to be done on the test windows, but if we really wanted to, we're going to miss the last 14 because that's the horizon. Can we fix that? Well, no, we can't because no, we can't. That's data from the future. Okay. So if we predict, what's the formula for moving average? How do we evaluate moving window? Yeah, so this was only predicting the next value. I need to, so that's model 2 pareds. Okay, these are the same length. So now what we could do is get the difference between the model 2 pareds and the windows. So this would be mean absolute error. Wonder if this will work. Beautiful. So this is what happens. Don't you love it when you just figure things out empirically? We need a way to calculate windowed results. So what if I did that by if this comes back with something, I'll be done. Okay. We need another function. Evaluate windowed preds. Of course, this makes sense. Of course, the models that try to predict further into the future perform worse. All the best, Vig. I'll thank you for tuning in. I'll see you when you come back, if you come back. For models. Ah. This makes sense. But I have a feeling we could potentially edit our evaluation function, wherever the hell that is. I've got a few ideas here, actually. Ladies and gentlemen, we may have just figured out how to evaluate our if we get the same value here, this will be great. This should work. Fish on. Fish on. Sweet, sweet victory. Now, if our data was in the form of tensors, so let's create a TF constant of model 2 preds. What's TensorFlow's? Can you ravel in TensorFlow? Flatten. Reshape. Boom. Okay. I figured out a way. We'll come back and do that. I'm going to take a quick break and I'll be back in like 5. How do I make lots of time series code? Where's a big whiteboard? Online whiteboard. Who knows a good app for an online whiteboard? Don't make me sign up for anything. Just let me draw. Got it. Excellent. B. R. B. Shit. Okay. BRB.
Can you remember the resource that helped you scale through the maths for machine learning course on Coursera? Where is it?
This book. This is a maths for machine learning book. You can get it for free online. I'd recommend this book if you're looking to learn the maths for machine learning. Use this alongside video resources. And like learning code, there's just no other way to learn it other than persistence over time. Lots of practice. Friends, I'm back. I can really feel the momentum building, people. Let's just get out of this tab. Leave. Boom. Boom. Haleo is right. Thank you for sharing that link. That's the MML book. Okay. Now, we're going to make this function work for arbitrary size of data. We just worked out that we can reshape a multi-step tensor into being a flattened tensor. Same thing with an array, of course. And we also worked out that if we get the mean, the way the loss metric is measured here is the mean across the windows. So we measure the mean absolute error across this window and then take the mean of that again, and that's how our loss function is working. So if it's good enough for our loss function, it's good enough for our evaluation function. Now let's figure out here, if we've got if window, yes, that's fine, but we're also going to turn it into tensors. Now we need to figure out if our tensors are, now of course we're going from NumPy to TensorFlow to NumPy, but that's okay because we're going to be using tensors later. I'll just keep it as that. Let's make it so that if our tensors are multi-dimensional, so if y true shape, so if we look at the original y test shape, if I get, does this have an ndim parameter? Ndim, yes, it does. And then if we look at test labels, ndim, yeah, there we go. So if our true labels, so if labels preds are multi-dimensional, are multi-dimensional, which means e.g. predicting more than one time step, reshape for calculations. Does that make sense? Nifs me? Am I saying that right? Nifs me? Maybe I'm saying that right. Maybe I'm saying that wrong. It's saying how many Pomodoro. Are you talking to me when you say how many Pomodoros have gotten done a day? I used to, when I was studying full time, I used to do 10 a day. Now I don't really measure them. I just do whatever needs to be done until I'm bored, because I kind of built up the habit of being able to focus, right? So although Twitch would argue with that because you've seen me get distracted, but I've got a pretty good skill now of doing one thing for 3 to 4 hours, which is usually, if I get 3 to 4 hours of deep work done on anything per day, that's usually like enough. Some days I need to do more, some days I do less, but 3 to 4 hours I find is like a good amount if it's solid work. So whatever that equates to in Pomodoros, I don't usually time them anymore. If I'm doing something which takes a whole bunch of effort, such as like responding to emails, I will do like one Pomodoro of that a day, typically outside, because then it doesn't feel like work. I don't like to respond to emails, even though I do. It just takes me a while. So if y true shape is greater than 1, we're going to reshape our tensors. So y true equals tf reshape but yeah, certainly if you're having trouble focusing, use the Pomodoro technique, but once it may take you like a year to develop the habit, But then you'll get into a stage where you can just work on one single thing for an extended period of time. TF reshape, and then we want to turn it into -1. This flattens it. Flatten the input tensor. And then y pred also is going to be flattened. And I don't like the fact that, yeah, let's bring this out. Let's do this first. Then we can have our conditionals down here. That's a much better way to do it. Yeah. I think this should work now. Cass is saying my dopamine is jacked. Do you mean that like negatively or positively? As in jacked as in it's very good, or jacked as in it's in need of help? Okay. Let's see if this works. And when I say like, because of the work that I do, right? And when I say like, I want to do 3 to 4 hours of just one task, that's also not just like reaching my concentration limits. That's also, because I don't want to be sitting down for the whole day. I want to be moving and getting around. So if I do any longer than that, my hips get tight, my jiu-jitsu gets affected, I get injured. Okay, let's see if our function works. All right, what did we get wrong here? Why do I have to turn that into an int? So tensor shape gets returned back as a tensor shape type. So this is what pisses me off about TensorFlow sometimes, is that it has all of these strange types that unless you explicitly convert them into a NumPy type or a native Python type, it doesn't work with any of other Python's types or NumPy types. So let's figure out how to hack tensor's type. So look, if I return this shape attribute, it gives a tensor shape. Now what do we have to do to get this into NumPy? Tensor shape has no attribute NumPy. Okay, we just have to index on it. But what if it's, no. What if it's multiple shapes? Ah, you prick. Oh. I stand corrected. I should have got ndim. Sorry, TensorFlow. My bad. Boom. We have a way for our function to now work for multiple dimensional data. So we can now tune different window size. Friends, this is actually very exciting. because now we can use arbitrary window sizes and evaluate the model's results. Yeah, Cass, I'm going to also get into Nephis all the best, my friend. Keep learning. That's all my advice is for anyone who's getting into anything that they're interested in. Because there's no secret. Absolutely zero. I've tried all the shortcuts. I've tried all the hacks. And it just comes down to follow your curiosity over an extended period of time. Challenge yourself, yes. Like if things are getting easy, well then find a challenge to take on. You'll get bored if things are too easy. So that's what I'm trying to convey with these streams as well. You're seeing me write all of this code. You're seeing me run into, yes, I'm interested in it, but yes, I'm running into a lot of roadblocks, and I'm picking up little things along the way. And it's collectively adding up eventually over time. If you want to get good at a skill, you can get, if you're going from zero and you want to be very good at something, it'll take you 5 years. But if you have enough persistence over time, over that 5-year span, you can be within the realm of go from complete beginner, zero, but then a dedicated 5 years, you can be playing with the best in the world. I'm being serious. So that's what I have to tell myself as well. But it's got to be a dedicated 5 years. It's not going to be half-assed. Okay, let's rerun this and just make sure everything's working. We're not just fooling ourselves. Wonderful. Okay, I'm very happy with that. Boom, turn into tensors. So now we have a way of we did this. So one of my favorite things in the world as well is deleting unused Jupyter notebook cells, because typically you make like 100 cells and then you'll delete 98 of them. It's a really good feeling when you can start deleting cells because your code must be working. Fingers crossed. Let's get rid of this. DKNG99, thank you for the follow. I got some big plans for streams going forward. Model. No, we want test windows. Yeah, test labels.shape. Okay, so now we've got an arbitrary way to evaluate preds of no matter what size they are. So if we compare model 2 to model 1, performs terribly worse. But now the trick might be, okay, so I'm not sure why model 1 results are blown out of the water too, but still, that doesn't matter. Our naive results, which is our baseline, is far and outweigh performing everything, which is expected. So now let's get rid of this, get rid of this. We're going to make a third model. Oh, cool. Welcome to Twitch. I'm still working the platform out myself personally, but I gathered it's quite simple. You just record your screen, record me talking, and do what I would usually do. Okay, now let's, before we can make a future forecast, we're going to do that in a second. I just want to make a third model and make sure that it works. So So this is where the experiments that we could run come in, is different horizon sizes and different window sizes. So model 3 can be dense, but with a 1 horizon 140 window. And the experiment we're running here is, the question we're trying to answer is, how does a larger window affect a smaller horizon? Model 1 looked at predicting the next one value, predicting horizon equals 1 with window equals 140, and then model 2 was horizon equals 14 with a window equals 140. So now model 3 is going to be a mixture of both. Horizon equals 1, window equals 140. And then we want to compare them all. Oh, I really wanted that to be dot points. Compare them all. Okay, now, so we need horizon equals 1, window size equals. Now we're really going to see if the functions that we've made before work. So this is the experimental phase of things, right? We try it out, see if it works a few times, then we scale it up, then we scale it up, then we slowly start adding complexity. Everything that we've built here, we've tested out like line by line. Now we've started to get a few levels of abstraction. So we want to remake train windows and train labels equals make windows on Y train. The window size is going to be window size. And the horizon, this is where we're really going to test how general our functions are. Remember I said before that we'd made a little breakthrough in generalizing our functions? Well, let's see if that was a lie or not. So now we're using 140 previous values to predict the next value, right? Because the window, just headbutted the mic. The window is the past, the horizon is the future. Yes, it looks like our function works. Terrific. Not actually viewing too many. Just going to view the first one. Build model. So again, just a simple dense model. We don't want to overcomplicate anything to begin with. Dense. We can start building LSTMs and convolutional 1Ds in a second. But as we'll see with forecasting, they all aren't very good. We want MAE as loss, nice and simple. Optimizer. I'll give this a name. No, it doesn't need a name. Model 3, fit. So right now, we're keeping the model the same. We're manipulating the data and seeing what happens. Of course, we could functionize this actually to do like a hyperparameter search with multiple different windows and multiple different horizons. Whoa. So I think this is our worst performing model yet. This is strange. This is why we experiment. Intuitively, I would have thought this is why. There's something broken with our test labels. Which also means there must be something wrong with our train labels. Because a neural network, remember, is going to fail silently and will generally learn almost anything you feed it. Okay. We've got something wrong. Oh no. Because the first label is going to be the 1/40th. So is it really performing that bad on... Huh. I wonder what the best sized window is. Wow. Okay. Better. What's going on? Okay. We're missing something here. We're definitely missing something here. Our function, we jumped the gun. We thought our function was... Okay, this will help us out, I believe. Ah, okay. No, we need... Derp. This should be test labels, Daniel. Come on. Okay, there we go. $6 a.m. No, that's nice and early for you. I've been streaming for a little while, but that's fine. That's the whole beauty of live streams, right? Is like it's not Okay, our function does work. We were just a little bit cooked when we were typing in the evaluation. So then if we compare this to... So we also do need a callback to save our best model results. What happens if we just train for 10x epochs? Okay, yeah, that's where we see the loss go down, but we also need a way to capture the best model. So that's another thing that we have to do. I think I've already put this here though. Let's now... What can we do now? Forecasting. Yeah, that would be a good idea. So, fix the make Windows function to work with arbitrary numbers. Yes, that works. Make the prediction evaluator work with different test size. Yes. Make forecasting better. How can I forecast on an arbitrary amount of steps? Create evaluation method for large... We fixed that, didn't we? Now let's work on this, forecasting. Here we go. So, what is the current window size? So that needs to be the input to our model. Do we have an input shape? 140. Okay. So let's make a forecast. This is what we want, eventually. So Model 3 forecast, we want to predict on Y test Yeah, that's what we have to do. Boom. Okay, so we got a forecast value. What does this make sense? Does this make sense in comparison to the last value? $43,000. So, but this is actually the next step. This is where we're going to see how poor time series forecasting can be. But if I wanted this model to predict more steps in the future, it would have to be retrained, which makes complete sense. Now we also want to plot. So we need two things for this. We want to plot forecasts. So let's write a function here. Beautiful. Okay. So we can now, let's fix this forecasting function, because once we have that ready, forecast. Let's see if this works on an arbitrary length data. Ho ho. Team, have a go at that. Let's get this in NumPy format, because that's just going to be easy to move it around. Yes. Yes, yes, yes. The dream. The dream is coming alive. Okay. Make forecast with one model. Oh. Typo. Am I even using a GPU here? Nope. Good. So why don't I get a moving average of this? That's going to be the moving average, isn't it? Because then it'll be the window. We are going to miss out on So we do miss out on a window worth of values here. Okay, so we're losing some labels off the back end here. Yes, okay, so that is where we're losing some. So So we need to figure out where this gap comes from. There we go. Welcome back, Vig. Oh, we've been pumping, my friend. I got a lot of thinking and walking to think about this. I want to plot the forecast and see what that looks like. Let's plot it and just see what it looks like. We need a way to Okay, now we're talking. But we need a way to adjust for the lag. That's probably the next step. I need to think about MK Window, thank you for the follow. Appreciate that. But we need to remember Model 2 Preds actually starts 140 time steps in the future. Yeah, so we need to so this is actually going to be, so we previously worked out that a Model 2 preds end 11 time steps before the future. So we need a way to push this back. That's looking better. Pseudo maze, what's good? We're just running into a mammoth amount of indexing issues. Okay. It makes sense that our model's going to lag on picking up the trends. No better TV emotes. I'll get the better TV emotes in a second to do. Okay. So I think we covered a fair bit of ground today. Namely, we made the fix make Windows function work with any arbitrary number of horizons. We made the prediction evaluator work with different test sizes. Forecasting, next is to make forecasting better. And I think we created evaluation method for large windows and horizons. So now we need to make the forecasting better. Then we can work on more modeling experiments and multivariate time series. So we'll probably do these two tomorrow, or these three. I'll put these in bold. And we'll probably move on from our NumPy windowing function to make a TensorFlow windowing function. So let's save this into the GitHub. This is a good fun stream. Update time series notebook with pre-processing plus prediction functions. Okay. Then if we go to the GitHub, if you want to see what we've been working on, the notebook is going to be available here. So that's in there. I've got a few things to do. I need to get the better TV emotes onto the stream for pseudomaze. I'll do that later tonight. And I'm going to do some research on Google Vertex. Vertex AI. So apparently there's a new Google platform for a managed machine learning platform that allows companies to accelerate the deployment and maintenance of artificial intelligence. So I'm not sure how this differs from AI platform. We'll see. but I'm going to have a look into that. And now let's also see what we got done if we git pull. Do we beat? Oh, we did. But a lot of this could be output as well. So yesterday we got plus 1,866. Now we have plus 2,827. So let's tick that off there. But I'm going to get out of all this. New ritual at the start of every stream is we X out of all the tabs. And we start fresh every day. All right. So I will see you tomorrow. Wait, it's better to do better TV on stream as it's a bit tricky. Okay, so should we do that right now then? Let's do that. Better TTV. Do I download this for Chrome? Am I in the right place? Overview. So I add this. Located. All right. So if I go to here, this is my stream. Am I in the right place here? Okay, log in. Logging in. Okay, so I've got this now. I can upload an emote. Okay, which emotes do we want here? Oh, obviously poggers. Boom. Do I search for GIF? Yo, it's Sheik, what's good? Pseudomaze, which ones? Can I just select any of these? The GIFs, I assume, are the moving GIFs. Cat Jam. Boom. Pepe clap. Boom. Are these all accessible now? party parrot. Yeah, you're right. Ashik, I need to get to Daniel Head from. Oh yes, this is a great one. I'm refreshing. Oh yes, it's there. There we go. What else should I get? What other dancing emojis are here? Is there Pepe laugh? There we go. We're on. Okay, we've got some more emotes. What should we do now? Franca faces. Connect with Twitch. Okay, boom. What emotes do we want? Are there top emotes? Where's the top emotes? Emotes. Public library. Here we go. Oh, obviously we want Pog. Add to my channel. What other emotes do we want from here? Pepe hands. Can I just add all? Five head. Added. Oh. Okay, this is great. I like that one. Thank you for your help, Pseudomaze. They're all poggers. Refreshing the page. Oh, I like this one. Hyper bruh. Omega. Oh, this one, yeah. Ashik, you're right. It is very important. Back to Better TV. You can create as many data pipelines as you want, or custom data pipelines with. This is beautiful, Suderman. We're glorifying the Twitch chat here, team. Hackermans. Which one should we get? I like the Pepe one. This one? Or this one? I like this one. Because that's me, right? This guy's jacked, so that's like me. All right, beautiful. So now, if you just type in Hackermans, it should come up with that, right? Wait, why aren't these coming up for me? They were just coming up, but they didn't come up. Are you seeing them on your end? What? Let's try this one. Sheik, what have we done? How do I remove existing emotes? Okay, now it should work. What? Okay. I'll fix this up later. Yeah, that's a good one. Capital POG is POG. All right. This has been a fun stream. Thank you for your help, Pseudomaze. Tomorrow we'll be back to do more time series coding and potentially fix up the emotes if I can figure that out. But thank you so much for tuning in. As always, keep learning, keep creating, keep moving. I'll see you next time.